Okay, uh, yeah, we're back, and so this is the biology related project that I took. Uh, yeah, and okay, right now what I want to do is just sort of merge a lot of data together and just have a single data, which I think was in this script, and after that we'll do some analysis. So right now it's just some putting everything in one place kind of stuff. So okay. So we're just getting all of the exported data from a device which exports all of this. So we have the minute. So on a scale of minutes, the heart rate data, the body temperature data. The body temperature data isn't all that reliable, so I guess I won't really be using that. But yeah, and then you have the heart rate variability data, which is actually uh, concurrently, so it's given simultaneously with heart rate. So heart rate variability, it comes in pairs. And then the day data is just summary statistics across days. Okay, so first we'll just process the data frames. So yeah, I mean, we'll just assign it some columns, we'll do some data type conversions and all that. And then for scene df dot columns print c comma dfc dot data type, we're just doing that just so we have sort of like a look at what the data is really like. And then you're doing day data is read CSV, and so will be only 1 GB. Okay, that's kind of bad. So I guess the problem is that I think I get what's going on. So if I do videos, and yeah, this is the thing, isn't it? I'm just gonna delete all of that. So delete this, and then I'm just gonna empty my trash. This is the this is kind of a problematic thing because I'm constantly dealing with low disk space somehow. Anyway, so you have day data equal to read CSV day data, user ID, etc. Short for C data dot columns print C day data C. It's just the usual stuff, right? Yeah. So for day data, you are doing it slightly differently. So first you are replacing the comma in your integers with nothing, and then so that you can convert it to integers. Then you do dot day equal to b dot date time, right? So you want everything to be in terms of date time, so that we can do a lot of like join operations easily. Because then that's hashable, right? Yeah. Right, so I'm not doing this thing. I'm not merging the body temperature data because it just like makes it bloated. But yeah. And then you just print the data. Let's first try to do this thing. So I guess I'm in the correct one. Do I have the merger script? I guess I do. Okay, cool. So just going to run that then. So run our merger. Yeah. So just get like the head. So sorry. So this first thing is just the day data. So it's on a scale of days. So at different days you have so this is for different users. So for each user you have some streak length, and for that amount of time you have a day data. Then you have day number, and then average day time, resting heart rate, average night, heart rate variability, and then you have all of these other statistics. So it's nan over here, fine, cortisol score, all that, and then you'll just be doing a join. So yeah, I'm not in particular getting only a few columns, right? No, I don't think so. And this is just like all the minute data. So after this is okay, this happens a lot. But anyway, so after all the data is merged, we'll have this thing. So The individual data frames for the different values, they were of these lengths, and now the new data frame is of this length, which is like slightly bigger than the largest one, which is like 8122,330 something. uh, right, so you just have heart rate and heart rate variability at different days, different times of the day. Right, seems about right. Okay, the next thing we'll do is we want to also have the this thing, right? So the day data, it contains where did it go? It contains a sleep onset and offset, right? So we want to merge on that as well. Now might just be better to substitute this thing. So it's user ID day number. So day is just a datetime object. Day number is like from the point at which start date, what day number is it? Yeah, it's for that particular individual. Cool. Streak length, so it's just like the total length. We don't really care about that, but fine. Then you have the bedtime start and bedtime end, which is what we really care about. You have the sleep durations, which I guess we can also use. Sleep efficiency, sleep score, average movement score is something which we could use. Average recovery score, average nighttime resting heart rate, average daytime resting heart rate, average night. So all of this is like really useful stuff. But then none of this is something that you would want to be merged with your data frame, like the big data frame, time series data, to do like any kind of operations. The only things that we really require are these: bedtime start and bedtime end. Yeah. Or maybe I could merge all of it, who knows. Day number. I don't think that's really useful because you already have the day, don't you? Do we need the movement score, the recovery score, the nighttime resting heart rate? I don't think so. We can just get it from this bigger, so this averaged data once like you're done with the time series analysis. Right. You do have the average night resting heart rate variability. Then you can get the same thing by just doing analysis, so not really useful. Then average cortisol score, etc. So what we really require is just the sleep onset and the sleep offset. Right. So for a particular day, when did this guy sleep and when did this guy wake up? So bedtime start and bedtime end. Now these are objects which I don't really like. Okay. Do we have the head of this thing? I don't think we do. I do not like this thing that they have it as objects, but okay. I guess we should change that. Anyway, that's the minute data, but we don't really want this. So we just want like only a particular portion of the day data. So day data important. That is day data. Dot. I guess it was log. No, I guess I can directly just slice this thing. Is this how we do it? No, I don't think so. I will have to do this thing. And then put all of the columns that we want. So we want bedtime start, and then bedtime end, and we also want, I guess that's it, right? Or we also want the things that we want to merge over. So user ID, and the day seems like the correct thing to use. Right. Okay, that's fine. Right, I'm just going to get that and then I'm going to print its head. I guess I should do a copy or something. I don't know. When you do LOC, you're kind of just taking a view, isn't it? Yeah. How do you take a subset of the data set? I'm just going to search that up. Pandas get subset of columns. Yeah, the usual with a list of column names. Oh, you can directly do this thing. Oh, that's crazy. Interesting. Wait, but then, so you also pass in the indices like this, right? Huh. Yeah, sure. I'm just gonna do the usual then. So just forget the log syntax, just do it like this. And I guess this is going to give us the thing. So that's the data important. Now you want to merge. But before that, let's just print the head of this thing. So print head. Yeah, sorry, this is just um, I was like coding in R recently, so it's just I've got so used to that I can kind of forget we don't do it like that here. Okay, let me just print this thing and let's see um, what we have. It's gonna run the same script. This should work, I guess. Bedtime, start bedtime, and these two are objects. I want it to be date time, right? Now, how was I doing that? Yeah, so pay dot do date time, and then I would just do the thing. Fine. And then I just do an assignment over there. That's kind of weird, but okay. I guess that's correct. So day data dot day equal to this thing. I should also do it the same thing for bedtime and bedtime start, I guess. I mean, depending on what these objects really are, if they're like integers, then that doesn't make any sense. But let's see what this is. Okay, so now it's gonna give us a merged thing. Right. So this is what we have. Bedtime start is something like this. So it's kind of like a date time object. But there's a comma over there. That is a bit weird. I mean, I can replace that, but still, it is weird. Let's just see what Gemini has to say about it. Or just Google. So, can this, so can strings of type be converted to date time, to period or date time, whatever, in pandas. So just period to date time, and then you also have the format. So format is this thing. I'm just gonna copy that. Cool. And so we'll do this thing. So we'll do like day data important dot bedtime bedtime start. That's just equal to the same thing. So day data important, or more like pd dot to date time. That's how we do it, right? Let me just check it once. Yeah, to date time, and then you would just pass in the series, right? I'm just gonna pass the same thing, but then you also want to format it. So format equal to this, and then it should work. So just copy the same thing. This is for the start, let's do the same thing for the end, etc, etc. And there we go. And now when we do that, it won't be like this, it will be like proper stuff, right? And after that is done, I guess the main thing would be to merge it with this thing. So we'll do a join on user id and day. That will give us an even bigger object, but I mean, it is the way it is, so sure. Right, so I'm just gonna say full data, or more like just minute data. I mean, minute data equal to minute data dot join. So this just does a left join, which is what we want, because in case there isn't a bedtime start or bedtime end, then like it's fine. It's fine. It's really just the values in this thing that we really care about. These are just so that we can build an indicator. That's about it. Like honestly, we should be doing all of this in SQL so that this is like all optimized, but then who cares? It's small enough that I can do it in memory. So minute data dot join on. So that's something I have to specify. Now we have two things. We also have to at least give the thing like what to join with. That's day data important. So we will join on user ID and the day, I guess. I think that should work. The time isn't so important. And that's just like the usual, right? Then you get the harder and harder reliability. And sure, so this should be the thing. And then, so you are doing this thing, but we also want to do the head of this thing. So print minute data dot head. This script should output what we want ideally. Let's see if it does that. I mean, if anything goes wrong, it will most likely be this. But let's see what happens. The crazy thing is like all of this is running on CPU, so I'm not even sure if I'm doing a good thing by keeping my recording on. Well, let's just see. Let's just see. Wait for it, wait for it. It's like that song that's in Hamilton, right? Wait for it. Like the Hamilton, the animatic. Animatic, or what was it? The thing that, the show, whatever. Oh yeah, so something weird happened. So, okay, must be equal to the number of levels in the index of right. Just a second. Oh, okay, I think I get it. Because the join thing actually just joins directly on the indices, and so this is messing up, isn't it? Yeah, so I just have to do the usual merge so that this works. I mean, this sucks, but it's fine. So it's just pd.merge, and then you just do the not data important, it's just minute data, and then this thing. So it's just left join. So I'm gonna specify that how equal to left. This should work. But at least, so was it able to do the thing? A value is trying to be set on a copy of slice from data frame. So it's better to be using lock, it seems. I'm gonna do that actually. So .lsc. Okay, this is the correct format, I guess. Okay, I think this is the issue. You have this going on, so I can just change that, right? I can just have something like this. Okay, I don't know what yeah. Okay, that should work. And just to be like extra sure, what I can do is just copy this thing, and then that should work. Okay, but now at least it's in the correct format, like it's date time now. That's about right. This isn't so, like, I could have just done it like from the get-go. Why even bother with all of this? Because the merging is going to happen with copying anyway. Yeah. Okay, this seems correct. And then you have something weird going on. So length of left must be equal to the number of levels in the index of right. Hmm. Okay, weird. I can do an ignore index, right? So ignore. I think there was a sense. I don't know. Left on. Oh, okay. So that is what was there. Index label not equal to the left index. Yeah. I mean, I just put an on over there, so this should actually work. Uh-huh. How and on. Yeah, that's fine. I'm just gonna go to the. Yeah, let's see what happens. After all of this like is done, I guess we'll have the correct data and then we can start some analysis. Let me just quick check something. The crazy thing is I'm also like managing a team on the side. So like some of you were asking why was I reading all of this like biomedical stuff, ultrasound and all that. I'm actually working on a system which is like an ultrasound system. So we are doing okay, what is going on? Important is not defined. What's the error? Oh, because it's that explains it. Yeah, sometimes I do make mistakes. I mean, I'm only human. Just run it again and just check if there's any error that I'm making. Yes, I should have put all of this in a Jupyter notebook, but who cares? I mean, as long as it's giving us output in reasonable time, it's fine. It's not like I'm going to be doing all of this like the whole day. What was I saying? Right. So I'm also on the side doing an informal project which was like building a TFM system, the total focusing method. I guess I can even show you the slides. Like you might really like this. Like this is just something that I got into. Yeah, I guess this is the thing. Sonic meeting. So this is all in Verilog. So effectively, like I'm doing the same kind of stuff that I was doing during my digital systems course, except on a much larger scale. So like TFM is one of the algorithms that's used in beamforming, which is like a part in any ultrasound system. It's like how you do it, the math and all. And I'm not going to go over it because this video isn't really about it in the first place. But yeah, like all these FSMs you see, all of the interfaces, this is like straight from the system that I'm building. And the idea is that like given a signal matrix, which is the captured signals, and the like dimensions of grid and all the other parameters, you want to reconstruct the image using the signals captured. Now this is how the reconstruct image should look. This is for something known as a side drilled hole, and this is for aluminum blocks. And this thing that you see on the top, I'm pretty sure it's from the ringing artifact. But anyway, so this is how the real image should, or more like the ideal reconstructed image should look like. So this is MATLAB code that like a whole team wrote, not us, not anyone at IT Chain, but somebody else wrote. And this is like Python reconstruction. This is software reconstruction, pretty easy. And yeah, this is what I did. So pretty much no difference, right? And all of this is happening through Verilog. So all the nice things that you have in software, you don't have in hardware, by the way. Like it's a lot more laborious, a lot more intricate. So I mean, I'd say it's a good thing that I got into all of this, because I've seen just such a massive growth in that department of my skills, that I think I might even be able to work on all of this like as a sort of side career. And yeah, it's just like the, I don't know, the math and the working of the TFM. I'm really not interested in telling you all about all of this, but just letting you know why I was reading through all that. Like, it's useful. There are projects that are going on this exact thing. So this is like, this project is coming straight from the Muse lab, the medical ultrasound engineering lab at IIT. They do stuff like this, and this is in partnership with a company called Modsonic. So I was presenting this in a meeting that Muse Lab was having with Modsonic. Uh, it's over some like 10 lakh budget for, you know, writing this system, and it's mostly just like normal engineering. Except it's not software engineering, it's more complicated. But yeah, it's mostly just engineering. There isn't a lot of science stuff going on. So this is like an informal project. I'm not doing it for credits, but the amount of work I've done, I'm pretty sure like it would qualify. Okay, who cares? Anyway, so we have our data, right? The main thing. So you see that the bedtime start is now in the correct format. It's all date time. So now we can use arithmetic on this, and that's really great. So we can just get the values. We can do a plus minus, that kind of stuff, right? So the thing is, the bedtime start and bedtime end is going to be there regardless in our like data for the user. So there's no point in actually storing it. It is like wasting memory. But then we already have it. Like, don't really care, do I? Yeah, I could just, so one thing is I could just create a sleep variable. And that I think would be enough. Like whether or not the person is sleeping. Yeah, just like an indicator in a sense. And whenever it switches from 0 to 1, we'll know that okay, that's where he started to sleep, right? Yeah. And then that is it. The indicator is really all we care about. We don't really care about the actual start and end timings. Yeah. Although we could potentially be using this, I don't know. Yeah, I guess I'm just gonna leave it like that. Like bedtime start and bedtime end, it's fine. Just leave it be. I think it's fine. We can just create the indicator in our analysis later. So I'm just gonna save all of this data to a file, which I guess, so since I'm using the 2024 to 12 CSV, wait a second, why am I using 2024 to 12? So you have 2025 to 3, and then so I'm using the CSV with the least amount of data. That's kind of bad, isn't it? Yeah, I should be using the full data set, right? So 2025 to 1, I guess. So this is 0 1, it's not. I see. Why is it like this though? I mean, what's going on? Why are there so many files with this particular thing? I don't know. Anyway, so this is for 12 years, like this data. I guess if I were to use 2025 to 1, that would be the largest data set, and that would have much more data than this thing. I could use that. I'm just going to define a time frame. Okay, so this is the metrics for 16th May 2025. Right. So 2025 to 5. What is 19T044614.16901Z.csv? I don't know what that is. Hmm. In any case, we will just be doing a left join, so it's fine even if you don't have the data, I guess. Because this is the only real thing that we have. It seems as if it's from 2005 to 2025, although I'm not really sure what this number even means. Like, it would be nice if there was something which would tell us what this is about. So I guess this was an inclusion exclusion. It's in docx. I don't like docx, but okay. So it's a PPTX. I read through these things. These are complete bullshit. Like, I don't know what that person was doing. But okay, so this is the data over which I analyzed the last time. So I guess I can use the same thing. But I'll just make that slight modification. So I'm just going to say time frame is 2025 to 12, and I can change it whenever I want. 24 to 12. Okay. Just do some format strings over there. So this is time frame over there. Okay, so this is our data engineering stuff done, and then we can just put this in CSV. So minute data to CSV, index is equal to false because we don't want that. What am I writing? Header is true, it's by default. And what is this going to be? The name is going to be so yeah, okay, so it's HR export, temperature export, HRV export, all that. I'm just gonna call it minute data, like yeah, just the most lazy kind of thing, but yeah, sure. So minute data dot CSV, that should work. I'm just gonna run this, and so it's gonna run for a while. Okay, now I gotta think about. So I'm just gonna show you the analysis which I did the last time. Not run anything, but just show you the results. So I mean, I imported SQLite, but I guess I didn't really use it, so I don't know what's going on. So I was doing it for two different users. This first user had a like really large streak length, and this is just the first user. So I just got the data, I read the thing, I get all this, and then I do some like conversion to sane values. So now the time is in hours and not that weird thing that we had, like the datetime object stuff. You just have to do s type int, really, that kind of changes it. And then you do read equal to df.metric value. So the metric value in this case was the heart rate because I imported the heart rate data. But yeah, just like looking at the data for now. Then I got this average data, and then I did this thing. This is for different days. So the only reason I did this because I wanted to have the bedtime start and bedtime end, and then the sleep duration is just the difference between these. And then I plotted this. So this signal is just basically when the person is asleep, and now we're going to create a proper indicator for this. So it will be like much better, but yeah. And then I did some cosine analysis, and I got all of this. Okay, cool. Now this is just the exponentially moving average. This is just a smoothened function. I should ideally be doing all of this in C, but then I don't really care because the data is small enough for me to be like doing this on Python. And this is just some widget that I created just for interactive like I was like basically training the cosine analysis on some portion and then predicting. So this to the left is the training data set, and to the right is the testing data set. So the idea is to forecast the heart rate levels at different periods, at different time values, and you can see it kind of works. Like qualitatively it works because whenever the person is asleep your heart rate should fall, and that's what we see roughly, of course, but yeah, that's what we see. So this person's heart rate actually fell over here, whereas it should have, I mean, yeah, this is the what the peak should have been. I guess the point is like it didn't forecast it all that correctly, and then somehow this guy just stopped using it, which I don't know why he did, but okay. And then over here as well, the sleep is like this, and then here's the sleep. So the idea is that these variations in the sleep onset and offset, they cause disruptions in the circadian rhythm. Because the circadian rhythm is like a control system. It's driven by different activities that you do, and sleeping is one of those activities. So just before sleep, you have this thing called DLMO, which is delayed. Which is the melatonin onset. Like, I don't remember the thing. What was the full form? What was DLMO's full form? Dim light, right? Dim light melatonin onset. So that's where your melatonin starts being increased, and that's the point where you have sleep, basically, like sleep starting. So that is like one of the things which completely determines the circadian rhythm, and it just so happens to fit very neatly with sleep. So basically, if you have the sleep time figured out, you also have the whole circadian rhythm thing figured out. We want to see whether weird things such as sleeping really low or sleeping irregularly could cause problems as in diseases, and the way to check for that is to check the heart rate variability, which is a direct indicator of the disease. So we just want a correlation between the two things. So we define social jet lag, and there are papers which already do that, which is basically like between two periods of sleep, whatever is the change in the timing, like the time of the day when you start sleeping, or the sleep midpoint, or anything like that. If there's a change, then you basically, like, there's some metric defined on that, if I'm not wrong. I think it was just a simple difference. Yeah, that was social jet lag, right? And they showed that this is correlated to many different diseases, and also, yeah, that's what we want to test as well. In our case, so you might think, why are we doing this? Like, this has already been done. Well, the population that they did it on were all Western, like, civilizations, like Europe and America and all that. Nobody has tested it on Indians, and so we want to do it because we know that Asians are a slightly different kind of breed, if you say race is what we'll have to say, but yeah. So we have slightly different genetics from people in the Western regions, so the effect might be lower or more on us. We want to test how that goes. This Instagram just shows like how frequently do people use this thing. There was another thing, there was this, like, these spikes in the heart rate, and that is mostly because the person is running, although they don't really mess with the analysis. Yeah, so even after smoothing there are these weird spikes. And this, as you can see, the sleep midpoint directly affects the phase. So what we want to do is separate this, so also account for sleep as a confounder. So yeah, have a different thing during sleep and during awake, right? Yeah, I guess. So during sleep, you might just have like a dip in your heart rate. And currently, the cosigner is like messed up because that dip is thought of as a trough, but then we don't know whether it's actually there in the circadian rhythm. So maybe it's just better to think that it's the combined effect of sleep as well as that thing. Yeah. So like there's some treatment effect from sleep itself on the heart rate. That's the way to think about it. So if I had to think about it in terms of causal analysis, it would basically be that sleep is a confounding variable for heart rate and circadian rhythm. Because what we're trying to show is that the circadian rhythm directly affects the heart rate, right? That the heart rate actually follows the rhythm. So if sleep is meddling with that, then it's not going to work very well. And you see that the results say that there's a significant correlation, but then we don't really know because there's a confounding factor. Because I mean, sleep is a confounding factor basically. So here's the stuff to do for now. We want to get the average heart rate for. So we want to do this on like the whole population given to us, and not just a single individual. So we want to get the average heart rate for each individual and the cosine parameters. So this is already done, like cosine analysis on the whole thing and then getting the thing, that's already done. But yeah, basically we want to like extract parameters for each person and then see what happens. Awake and asleep cosine need to be separated. Second or third week of February is when I have 5. Oh wow, okay, this is weird. I don't remember this, but okay. Awake and asleep. This is what we're going to do right now. Actually, that we're going to separate the asleep and awake cosine. I'm just gonna see what the result is. Okay, I think it's stored. Spikes and heart rate is most likely running, so we want to remove that as well. That if it's too high a variation, it's probably that the person is running. So we want it to be removed, not just like dampened, but straight up removed. Yeah, so we'll constantly track the heart rate variability, and if it just happens that it's going way above what the normal level should be, we'll say it's an anomaly or it's the person is running. We can also use it to get the activity data, which we'll be getting anyway, but maybe just better to for now remove it. Okay, so I'm going to create another notebook and mostly just copy the code, but this time we are going to use this new CSV file that we have created, which is minute data. So it's going to be a big CSV file. It has like lots and lots of rows, but like let's just have a look, or maybe not, because it might just hang my computer, but yeah. Okay, so let's create another notebook. So this is also more or less exploratory data analysis, because I'm not actually exporting any coefficients or anything like that right now. So EDA not 2, it's supposed to be 3, not IPYNB. Okay, so the usual, I guess I should just open this at the side. Oh wow, that's not what I wanted, but I mean that also works because PDF is easier. Okay, let's keep going. I'm just gonna close it again. I'll also close this thing, we don't need it. Okay, so first we just get the libraries. Okay, and then we just import all of this because we need all of this. Oh my god, I don't want to do that. Okay, the kernel is Python. Is get the libraries, import this. Okay, data. Okay, cool. Getting data. So the file is now not this thing. It's just minute data. .csv, and then we want to do just data frame. And yeah, just do a head for now, just to see what it looks like. This might take some time though, because there's like lots and lots of rows over there. So for this one, as you see, okay, there's no time written over there, but okay, cool. I estimate it might take like I don't know, half a minute to just get the thing. Also, Jupyter has this annoying habit of crashing. Uh, but yeah, I'm going to risk it and see what happens. Oh wow, oh wow, really? That's the thing? Fine, I'm just gonna get the thing then. Yeah, sure. I mean, I guess TF is already there, so I can just do it in the next cell. Yeah, that's the thing. So, user ID, day, time, and the heart rate variability, bedtime, start, and so on. So, the user ID that will use. Okay, so it's just two data. I'm just gonna also. So, there's head, but we also need to just look at the columns. So, for C in df.columns, I'm gonna print C and its data type such as dfc dot dtype. I think there's like an easier way to do this, but I am lazy. I just like to do this thing rather than reading code. Okay, so bedtime start and bedtime end is still objects, which I do not like, but we can convert that. So this is in the correct format though. Yeah. Why did it not think of it as even time is now an object? Huh? That's weird. Okay, fair. So I guess we'll just convert all of it. So we'll read CSV and then how do I specify the data types? Pandas, specify data types and reading. Yeah, that's what I wanted. So I just pass in the day type, huh? For specific columns. So you just put in the column names and then you do this thing. Oh, okay. So to correctly parse date and time columns into datetime objects, use the parse dates and date format parameters instead of dtype. So I have to put in parse dates. Okay, parse dates and then put in the columns. Okay. So the columns are in particular day, time, bedtime start, and bedtime end. Yeah, that's the thing. I'm just gonna put the head over there. But sure. Hey, the head is over here. Let me just get this thing, and then just do it over here. That's probably the thing. Well, let's run this again. Let's see what happens. I'm hoping it gets corrected.